then including the data discretization, integration, transformation, and reduction. Yeah. Okay. So why would be very important for us to deal with data? Because most of the problem with data, yeah, if you deal with data, if you see something that you can have in the WECA, probably in the ARF viewer, yeah, as you see the data can be seen that gray area, yeah, gray area or something that related to the empty cells. So this will be incomplete, yeah, and most of the time is known as the missing data lah. Okay, how about noisy? Have you any idea about noisy? This is example, salary. What's the error?
Quotation and the minus sign.
Yeah, negative.
Okay. Negative. Quotation should be okay because quotation will be showing that this is considered as a string actually. But salary normally is being detected. I mean, we put salary in the form of numeric. So this is actually an error lah. So the quotation should be not there, right? So if there is a quotation, is actually a string, and then the negative value is also, yeah. The next one, how about inconsistency? How about inconsistency? As you see here, age 42, okay, and then the birth date is 1997, okay. If you calculate for, imagine this is 2021, what actually the age for those who born in 1998, 97?
24.
24. You all 24 ke 20 berapa? Ya, sampai 24. Muda lagi. Okay, alright. Okay, so mostly semua lahir tahun 90 berapa tu? 2000?
2000.
2000?
Yeah.
Oh, ya. Oh, bagusnya you all ni semua. Apa memang is a millennium, ya? Yeah? Millennium babies. Okay. Right, the next one, if you look at inconsistency in terms of we put the rating, yeah. So some of them you are using 1, 2, 3, and then some of them you are using A, B, C. Yeah. So A, B, C should be consistent, like whether you want to use this one of this, yeah. And it also can be occurs in records that might contain duplicates, yeah. Okay. Right. So how you are going to deal with incomplete or missing data? Yeah. Before that, we should know that how this data or this problem occurs because of not the availability. Yeah. So we consider that's why when you want to deal with data mining, you need to identify the variables and so forth. But there are certain things you thought that this variable is very important. But it occurs that when you want to collect the data, it's very hard for you to get the information for each. So this will be one of the main problems. So somehow, due to this attribute might not be used, yeah, for the modeling purpose. Okay. And if you look at other causes of missing data would be due to the equipment, like you are taking data on the temperature, you are using sensors, yeah, like also you are using handphone, right? You are using a handphone and then you are traveling to somewhere, so you are using Google Map and so forth. So it's depending on GPS, right? Okay. So what happened when you goes into the tunnel? What happened?
No service.
No service, okay? Ataupun you terlindung in between of the in between of certain area, yeah. So that will be some problem for this data. I mean these sensors or these devices, yeah. Okay, it could be because of misunderstood, yeah. Some of the when you deal with data collection, yeah, you need to interpret the data and somehow it might be involve a different perspective or different understanding. Yeah. Okay. All right. So how you're going to deal with the missing value? Yeah. So as you see here, there are many somehow like this. Yeah. This is where incomplete totally. If you look at the WECA, it will shows like 90 says that 80 to 90% missing value. Okay, what do you think? If you had 80 to 90% missing value in this variable, what do you think?
We drop the attribute.
Okay, good answer. So we cannot depend on this attribute. Means that this could be removed, yeah, totally. Okay. What if there is something that you could you can compromise like this one, yeah? The missing value would be less than 20%. Okay. This is what you have done yesterday, and those who are going to do today also, yeah. You could use the functions of replacing, yeah. So you can replace the missing value. Okay, so what value do you replace, yeah, actually here. Okay, let's have a look at. So here, like you see, yeah, it could be just now you see the data is for based on the attributes, but somehow there will be also some kind of problem that the tuple itself, yeah, the tuple do not have the labels, yeah. So historical data do not have any target or the class label. So this would be insufficient for the algorithms to learn about the patterns or learns about the data. So this one, those tuples that has lots of missing value for the attributes also can be removed. Yeah, it should be removed. Yeah, and then how about filling it manually? What do you think? Okay, those content of 90%, contains of 70% missing value, it could be very tedious. Yeah, it is invisible. If you have to do manually, means that you have to identify the resource. Yeah, the sources of the data. Who will this data set is belong, or this records is belong to whom? Okay, so you need to identify this person. You need to identify the objects of this record. So it sometimes very tedious, and it is invisible for you to get the original source of this data. Okay. Yeah. So filling it automatically, this can be done by replacing with unknown. Yeah. So it's considered as a new class. Okay. How about to deal with mean value? What is mean? Yeah, mean value is average. Good. All right. And then, or you could also, yeah, this one is more rigid. Yeah, this one is quite rigid. Just now it's just focus on mean only, means that mean of the attributes. Any value, any not necessary whether it's a different class level or not. But if you look at the second part, yeah, this is a rule based. Yeah, this is some kind of rigidity to the implementing of the rules for specific replacement or cleaning the data. Okay, to confirm that the quality of the data is much more better. Another method should be done is by looking at the class. Okay, for example, you are talking about the temperature, and then you want to know the class level, whether it is sunny or day or sunny or rainy. Okay, you want to replace the temperature value. You have to look at whether the mean is representing to any class level values, or only focusing on the rainy only. Okay, so you have to divide into your data set into same class level first, get the mean value, and then replace it. Okay, or somehow you can use the Bayesian. Okay, so this would be the beauty that what you have learned last semester, yeah, related to the Bayesian. Actually, there is another 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 set of slides, but I skip that one because this that slide is actually in the video. Yeah. Okay. Okay. Next is about noise. Yeah. So noise could be errors happen can be found in the variables lah, like what you have seen before. Okay. So this error can be cleaned or can be smoothed by removing this noise. How to remove the noise? So this is what you can do, yeah, by using binning, or this is more considered as formula, yeah, that you are using another specific formula or another supervised methods for regression is supervised, meanwhile cluster analysis is unsupervised methods. Okay, so we are going to look at it later on. Okay. Right. So I hope that you understand what is noise. Just now we have seen one of example noise, isn't it? Noise yang mana tadi tu? Can you recall what is
negative 10?
Okay, good. All right, good. Okay. Let's look at how you are. Okay, the first method to deal with noise is performing discretization. What is discretization actually? So discretization, there are two techniques which are one is the equal width and the next one is equal depth. So what's the difference between these two? Okay, so if you look at the width here, it's actually one way by looking at the range of the size. Yeah, the range of the bin. Yeah, bin should be same. Okay, so how to do that is by looking at the lowest and the highest of the value, yeah, of the attribute. So definitely here, when you want to apply binning, it will be suitable for what type of data? Can you apply it for nominal?
No.
So you need to, you have to make sure that your data is a numeric form, yeah, so that we can have the lowest, minimum, and the maximum. So how to get the bin? For example, you want to set bin equal to 3. Okay, so n value is equal to 3 and b is the highest and a is the lowest. Then you can get the range. Okay, and then how about equal depth? Yeah, equal depth is referring to the frequency. Okay, so you could get, yeah, you could assign or set, you have to set it in bin equal to 3, but the range of the bin would not the same. Okay, would not the same. Okay, so what will be the common thing for each bin? Any idea? Apa yang sama dalam this technique for each bin? Any idea bila you baca description ni? Apa dia?
Value dia ke, madam?
Value tu value apa? Tadi tu kita reflect kepada value of the range. Interval kan? Tadi equal width tu adalah value interval or the range must be same. Tapi for equal depth definitely different lah. Dia tak akan sama lah dengan equal width. What will be the same value? What will be same value for ataupun apakah kriteria yang sama untuk setiap bin tu? What do you think? Apa yang akan sama? Any idea? Ni nampak tak ni? Apa dia kata? Apa dia tulis?
Same number of sample.
Apa yang maksudnya same number of samples? Okay, so
Frequency.
Here, frequency count lah is actually referring to the count of samples. Okay, so here under equal width, the range of the bin will be same. But here in equal depth, your range will be not same, but the number of frequency, the number of count, number of count samples lah, we referring to the samples, would be same or similar lah, similar. Okay, let's have a look at the example. Oh, before that, here, okay, on and on the methods of doing binning process, so it's actually can be binned by means, can be binned by median, and can be binned by boundaries. I mean that after you have the bin, so how you represent the bin, okay, so here for example there is a set of data that you have, okay, representing the price for different items, different items, and then you want to have a equal frequency, equal frequency, if you look at equal frequency here, bin 1, bin 2, bin 3, okay, so remember frequency is reflect to the samples, right? So that's why you see here in bin 1 there are 1, 2, 3, 4 samples. The second set bin 1, 2, 3, 4 sample. But if you look at the range, can you get the bin 1, the range for bin 1? Macam mana dapatkan range for bin 1 ni? Lowest? Yeah, good. What is the bin here? What is the range here? This is 11. If you look at the second bin, 25 minus 21?
4.
4, right? And then the third one? 34 minus 8. So as you see here, range dia sama tak?
Tak.
Tak. Tapi again, because this is equal frequency, so the range will be not same, but the counts or the samples must be same. So you have 1, 2, 3, 4 here, 1, 2, 3, 4, 1, 2, 3, 4. Okay? Can you see the difference? Boleh faham? Okay? Right. So and then here, when you already have partitioned the data, there are another methods what you call as the smoothing. Smoothing. So you can smooth the bins using the means value. Okay. So means value is 9. So bin 1 will be presented by 9. Okay. And then the second bin will be presented by the average value of the bin number 2. So you will get 23. It means that 21 plus 21 plus 24 plus 24 divided by 4, then you will get 23. Okay? So do you know how to get this one, 29? Do you know how to get this one?
Yes, add all then divide 4.
28 plus 26. 26 plus 28 plus 29 plus 34, right? Okay, so this is what we call as the smoothing by bins, and then the second one is the smoothing by boundary. Okay, right. So wait. Okay, so let me have a. Okay, so if you look at bin, so there will be 2 bin, which is what we call as the apa tadi? Equal
width.
Okay, equal width. And then you will have what we call equal
depth.
Ataupun frequency, right? Okay, and then after you have the bin, next you are smooth. You can smooth the bin. Okay, how you smoothing? Which is based on the mean of the bin. Okay, or the next one is by using the
boundaries.
So boundaries for this one or boundaries for this one. Okay, understand? Boleh? Okay, Next one is, this is example lah. This is just example. I think later on you can have a look at the example and look at this. Yeah. So this is actually the range. As you see that range will be same. This is bucket. Yeah. Bucket is a bucket or bin lah. We call it bucket of bin. So 1 to 2. 3 minus 1 equal to 2, and then 6 minus 4 equal to 2, 9 minus 7 equal to 2. So the width of the bucket is 2. Okay, and as you see, different count is shown in the bar, in the bar chart. Okay. Histogram is very popular, being used for the binning outcome. Yeah. So actually for each of these could be, that's from here, you have a numeric. Okay, now when your data is presented like this, it's actually a nominal data set. Okay, have a look at equal depth later on. Okay, how you get this one. Okay, right, so have a look at the other methods. Okay, so we have gone through a noisy dataset by using binning just now, or discretization. Okay, now have a look at clustering. So clustering is considered as unsupervised. Okay, so how is performing? How do you performing? How do you clean? How do you clean the data or noisy data using the clustering? So as I shown in the topic 1, so clustering is looking at the key point of clustering is saya salah eja, okay, similarity. Okay, so the key words in clustering is similarity. So this algorithm will look at each of the data. If the object is the distance of the object is minimized or very small, so it will be formed in as one cluster. Okay, and this is another cluster, and this is another cluster. Okay, again, your attribute could be in the form of numeric. Now, can you see? This is now, can you see? You already have 3 clusters, isn't it? Okay, so what happened the rest? The rest will be it now. Yeah, the rest will be enough. When you create, when the algorithm identify 3 clusters, okay, meaning that your data is being transformed from numeric to
nominal.
Yes, good. Right. So you have another way of presenting your data set. Yeah. If before this is a numeric, is now being presented as the nominal. Yeah. Same like binning just now. It's just another method. But don't worry. Okay. Probably now you cannot see how this method is being done. Okay, or how similarity is being calculated. Okay, this one will be covered nanti later on, yeah, under clustering. Okay, but what you have to understand is that again, yeah, this data set will be presented into several cluster, number of cluster that initiated by the user. Okay, you could want to have 3. We want to have more cluster, like you want to have 6 cluster, also can be done. Yeah. Okay, right. So the next one is regression analysis. Okay, so what is regression analysis? It's actually something that we have done last week, which is y equal mx plus c. Okay, so what does it mean? What does it mean? Okay, so here as you see, we have x1. Yeah? For example, we have x1, we have x2, we have x3, x4 until xn. Yeah, says that here you have the value, here you have the value. This one you do not have the value. This one you have the value, and then this one you do have the value. Okay, and along to x value, you are also given the y value. Okay, and then each of the records have Y value. Okay, and then for this missing data, okay, you can actually replace the value, or you can find the value. How? Okay, how? So actually you can use this formula y equal mx plus c. Okay, if you remember, this actually will be presented by y is the target here. Okay, mx is the coefficients here, and then c is the intercept. Okay, so for x4, right, for example, for x4, you could know the value of y here. For example, y is given, so you can identify where is your y, like this, for example, da 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 da. Okay, and then you drop down here, then you will get the value of x, or the other way on. For example, okay, x value given, but y value is not given. So how do you know the y value? So probably you can, yeah, you can extend the line into the trend line, and then you can get the y value. Okay, so understand the concept? Okay, can get the concept? All right.
Boleh, boleh.
Okay, so this will be how you deal the noisy or missing value, or it could be something that will be outliers also lah. Yeah, actually. Okay, so other than linear regression, you could have several variables. For example, here you have x1 and also x2. So this is known as the multi-regression. All your data will be in the numeric. This one is data in the numeric. Okay, and you could have another data will be in the what we call nominal, right? So you could use another formula. Okay. Okay. Inconsistent, yeah. So so inconsistent will be something that will be also considered as can be clean, yeah, and it can be corrected. How you want to correct the data? One way will be looking at the sources of the data. Okay, or other than that, you could also performing the discretization itself. Yeah. Okay, let me check this one. Okay. Okay, wait So let me repeat just now. So if you have noise, yeah, or you could have error or inconsistent, right? So you could have the concept of binning just now, okay, and then you could do apa tadi? Clustering. This is data cleaning lah. So clustering methods. Okay, and another one will be using the
Regression.
good, yeah. So regression. Okay, so actually you would have a lots of techniques under regression. Same goes clustering lah. Okay, there will be another. For example, you can use SOM, or you can use k-means, or you can use hierarchical and so forth. And under binning, it could be basic concept equal width and or equal depth, which also you will have smoothing method. Yeah, so this is what we have in the cleaning. Yeah. Okay, so another important techniques that can be implemented under the data discretization would be the concept of hierarchical. Okay, what is hierarchy? Is been used for numeric data. Okay, and then it also this will be numeric data can perform these methods, but when you are having what we call categorical or nominal data set, Yeah, so it would be another methods that can be implemented, which is concept of hierarchical. Okay, so concept of hierarchical is actually showing the count. Yeah, showing the count like this. Yeah. Yeah, actually it also can be done in the numeric, means that we put the range. This is like binning lah. Yeah, if you look at it, is quite concept hierarchical. Concept of hierarchy based on the binning methods, we identify how much bins that we want to have, or splitting bars that we want to have, and then what will be the minimum and maximum bins. Yeah. And then if you want to done it on the nominal, okay, so it must be done based on the schema level, and you can do this by reference to the expert. Yeah, like what you want to do, the concept of hierarchy. I mean, this could be related to what we call rank. Yeah, rank, which will be the lower and which ordinal. Remember ordinal? Yeah, remember ordinal? Okay, which will be the lowest and which will be the maximum, like this. Street, yeah, street is the lowest attributes compared to, and then we have city, and then next we have state, and lastly would be the country. Okay, so how you know street is actually the lowest hierarchy, ataupun the minimum hierarchy is actually by looking at, if you have a certain data set, the scheme of the street could be presented. Yeah, the count of the street will be more compared to the city. Yeah, and if you look at state, definitely like Malaysia, you have only 14 states, and then inside the 14 states there will be lots of cities. Yeah, and then definitely only one country lah for Malaysia, presenting for Malaysia. Okay, so this is how you another way of looking at the concept of hierarchy could be if you look at rates of salary, like how you define some kind of certain type of jobs related to the B40, M40, and T20, something like that. Yeah. So this will be helping the producing the hierarchy of the attributes. Okay. Yeah, another important point will be the relations and also the semantics. So this will be referred to the expert. Okay, the next so we have done on the cleaning. Okay, the next one will be on the integration. So when you have data set, and then you want to you look at the data set, and then what you have in your data set is insufficient. Okay, insufficient says that you only have data about the demographic, but you do not have data on the salary or specific related to the occupation. So you want to integrate this data together, so you could have more meaningful customer data set. Okay, so this is where you would refer to multiple sources. Yeah, so here, yeah, the important part will be multiple sources. But again, if you look at when you are dealing with multiple sources, you could see that the representation of record could be numbers. Yeah, the ID and so forth could be different. Like one, like just now, records of demographic will be represented by your IC numbers. Okay, but if you look at the occupation record, normally this data will be presented by certain employee ID. So when you want to integrate it, you need to find a primary key for both rows data set. So probably for the occupation, when the employee ID might not best value to be referred, so you need to also integrate it and represent it based on the what we call IC or my card. Yeah. Okay. And then some other conflict might be occurs too here if you look at representation. Yeah. Temperature could be in Malaysia is presented in Celsius. Other places might want to look at Celsius is to, I mean, the value of Celsius is to what we call, if you want to look at the temperature of places that very extreme weather, yeah, extreme weather. So we are talking about extreme weather. So Celsius might not presenting well on the temperature. It could be have to be depending on other measures like Kelvin, and selain daripada temperature Celsius is Kelvin. Okay, and same goes to the distance. Yeah, same goes to the distance. If you are talking about distance of city 1 to city 2, what are the measure that been used normally? Kita gunakan measure apa?
Kilometer.
Kilometers, right? So, but when we are talking about social distancing, penjarakan sosial, kita gunakan apa?
Meter.
Meter. So takkan kita nak gunakan kilometers. It's not suitable for us to use kilometers, right? Because of the scenario to represent the farthest and then ataupun the nearest, yeah. But when you want to put it into data mining, you have to make sure the measures must be same, yeah. Okay. Right, and then when we deal with the data integration, yeah, also another factors that need to be looked at would be the redundancy. So how you deal with the data identification, like you have to look at the same primary key, yeah. That's how we look at the records. Okay, how about just now we are looking at the samples, yeah, different samples and so forth. Okay, how about the attributes? There are some of the attributes could be redundant. So how you are going to deal with this redundancy? Okay, can you imagine what does it mean by redundant attributes? Can you imagine? Or can you give example of your at your knowledge? Ada tak?
What about attributes that hold first name and last name? Is that considered as redundant?
Names actually normally, okay, name is quite unique for everybody, okay, and yeah, you can use it, but we cannot, when it's too unique, yeah, it's hard for us to look at the dependency of these attributes. Imagine something, two attributes, and it could have dependency. Anything.
Monthly salary and annual salary.
Monthly, yes.
Monthly salary.
Okay. Yes, good. So monthly salary and annual salary. So means that monthly salary is actually presenting every month, but if you put annual salary, is actually presenting the total of the salary. We can have the monthly salary by getting the average, like 1000K, for example, divide by 12, then you can get the monthly salary, more or less lah. You can get the average salary for that. So it's definitely, it shows redundancy, isn't it? Betul tak, Natasha? Yeah.
Betul.
Yeah. So other than that, yeah. I believe you have learned fuzzy. Ke semester ni you learn fuzzy aspect
Semester
system?
ni.
Yeah.
Fuzzy. What is the classical example under fuzzy? Ada tak? You buat? Dah start belum? Have you done an exercise for height versus weight? Dah buat?
Belum kot.
Belum.
Baru
Okay.
height je banyak.
Baru height saja. So what do you think? Height dengan weight, so can you create any correlation for that?
BMI?
Yeah, definitely. So that is something that you might relate to. It means that this data, these attributes, you probably consider one of the attributes. You not necessarily consider both. Yeah, because height will determine the weight, or can be. I mean, if you are technically is a common understanding. If you are taller, means that your weight could be higher, kan? Betul tak? Lebih besar. Something like that lah. Okay, so this will be a correlation that you could have. Yeah, so when you have this set of attributes, actually you can identify whether it has correlation. If it has correlation, you can remove one of the attributes. Okay. Right. So this is how you do the correlation analysis by using the chi-square test. If you remember chi-square test, have you learned about chi-square test in statistic? Pernah tak? We are not going to calculate it lah. Pernah kan? We are not going to calculate it. Most of the time now, if you have gone through those calculation now, in the face of we are applying all this. So we can apply chi-square test for the nominal, and then meanwhile for numeric we can apply the correlation coefficient, like what you have in the linear regression is also known as the coefficient. So what is the results that you need to get is that if the relationship between P and Q is actually a variable. It's a variable P and a variable Q is positive correlated, means that the correlation is becoming stronger. Yeah. So it's always correlated. So you might not to take these two variables. You only consider one one variable only. Okay. How about zero? Zero shows independency. Okay. How about P and Q? So it's negatively correlated. Okay. Okay, so this is part of the integration. Is part of the cleaning. Any questions so far? No, Ada tak questions? I hope there is no questions. Okay, saya pergi lebih laju sebab ada banyak lagi actually. Okay, so integration ni I think I have done it. Wait ah. Integration I have done it. Okay, but you can make reference to the slides lah ni later on. Okay, and then what is the B sudah. Okay, let's have a look at C sudah. Okay, transformation. Okay. So transformation will be another that you have done in the beginning. Yeah. Can you guess like what you have in the beginning? You actually transforming numeric to kepada apa?
Nominal.
Okay, so it's actually a transformation process like you have done in the clustering also. At the beginning, the data is distributed and the value is presented as numeric, and then you form clusters actually, and then cluster will be actually presenting the nominal value. Okay, so it involves smoothing, or it could be it could be applying the aggregation. Yeah. And you could also implementing the generalization, normalization. So I'm going to touch this one. It's been done. Okay. So we are going to look at a little bit on the aggregation, normalization, and also attribute construction. I will give some of the examples only. Okay. Okay. So this will be the aggregation, like what Natasha mentioned just now. Natasha mentioned that there is a data on the months. Okay. And then actually there is a attributes for the yearly. Okay, this shows what we call as the aggregation or summarization. Okay, your data can be, rather than you put it into, there is sample of data showing like this months January, and then it has February, isn't it? and then it has March until until certain time lah. Okay, so actually all this data can be combined. Okay, it can be provided what we call specific value summarization. Like you can summarize it in the form of summary, or is equal to total of each value, or you can have in terms of average. Sometimes you want to have the average only, or you want to have the mean or max. So that is summarization. Okay, and this actually, from the summarization, is actually the new database being formed. Yeah, this is what we call as the data cube construction. Okay, right. So we are going. This one is also already done just now. So okay, so normalization. If you look at normalization, okay, what you have done yesterday is one of the tasks. Okay, and also another class for this afternoon, you will do what we call as the normalization. Okay, mean max normalization. Okay, so mean max normalization means that the data or the value of the attributes is presented into smaller range. What you see here, smaller, yeah, original is minimum is 12,000 and the maximum is 98,000, and then it's presented as 0 and 1. So how the transformation process been done based on this formula. Okay, and it's been means that you would have the mapping will be at the end, the result will be 0. For this data, you will have 0.716. Okay, how about Z? Yeah, how about Z score normalization? How about Z score normalization? Sambil-sambil ni boleh record your data, your attendance. Z score normalization. If you look at Z score normalization, there will be this is the value of. This is the value of the attribute. The value of the records, and this is representing as the mean. Sigma is the standard deviation. Okay, so Z score the records, the value of the records minus the apa dia di sini? Mean, okay, mean divided by the standard deviation. Okay, so this will be the new representation, Z score representation. Okay, the last one is decimal representation. Decimal representation, V divide by V divide by 10 prime. Okay, 10 power prime. Okay, so V is the record value. Okay, and what is the 10 power prime? Yeah, the 10 power prime is referring to the smallest integer. Yes, smallest integer. Okay, for integer means it's looking at the absolute value, absolute value of the integers. Yeah, so no matter is whether it's a negative or positive, so just looking at the value only, absolute value. So 986 to 917, what is the maximum? Is 986. Okay, and how many decimal value here? Berapa decimal value dia? Okay. Kenapa dekat sini dia dapat here J equal to 7? J equal to 7. J, if you see that, J equal to 7. Sorry, J equal to 3. How they get J equal to 3? Any idea?
10 the power of 3.
Kenapa? How you get the power of 3 this one?
Oh, tak tahu.
Any idea? Baca description dia ni, where J is the smallest integer. Yeah. So we have kat sini, ke you tak nampak kat sini? Nampak kan? Negative 9, 8, 6, 2, 917 kan. So yang if you look at the absolute value of the range is 986. Yeah, 986 is the maximum absolute value. Okay. Why absolute? Apa maksud absolute? Apa maksud absolute? Kita remove. We remove the sign. So we only consider the value itself. Okay. Now if you see 986, yeah, what is the integer size of integer here, which is 1, 2, 3. Okay, so 1, 2, 3. So that's why here j equal to 3. So the formula will be 900 divided by 10 power of 3. Yeah. Boleh? Boleh macam tak boleh je. Okay. So in case your range is like this, yeah. In case you have range like this, like this. Yeah. Okay. Okay. So 9, 8, 6, 7. Okay. To 900. Okay. So what is your J? Just now you have 986 to 916. 916. J is equal to 3. This one, how about this?
4.
J equal to 4. Betul? Any other idea? Betul? So this one is J equal to 4. Yeah. So it's equal to 4 because this is the smallest one. And then when you calculate the, but it's referring to the absolute. Macam mana tu? Maksudnya kita remove the sign. So the smallest one adalah 900, isn't it? And then, so sekarang ni, what is the integer? 1, 2, 3. So masih lagi, masih lagi 3. Okay, understand? So that is how you use what we call the decimal representation. Means that looking at the smallest integer. Absolute. Remember, you have to remove the negative value in case you have the negative value in the data. Okay.
So madam dia steps dia kena tukar absolute dulu baru check yang mana smallest.
Yes, betul. Exactly. Alright. Okay. Right. So ini adalah tadi tu kita discuss the smallest integers. Okay. Okay. And then we have feature extraction. Like what you see here, feature extraction. This is raw data. Okay, raw data. And then when you have you transform your data, definitely you might involve some kind of calculation, so you process data and in the end you could see this would be the color scheme of it. So if it is in red, it's what is red? Okay. Dah nampak ke? Oh ya ke? Alamak. Okay. Okay, signal saya. I'm losing my signal sekejap. Okay. Hello? Boleh dengar Boleh dengar?
Boleh.
Okay. Alright. Okay. Saya tak dapat pun notification, biasanya dia keluar. Okay, tak apa. So this is data transformation, means that you have data and then the object, each object is presented in different color scheme, and then as you see, it could be presenting as one object, another object. So actually, for example, you want to identify certain object, so you could use colors as the apa nama representation, ya. Okay. So colors ni can be represented as RGB lah actually, ya. R, yeah, red, and then you have green and also blue. Okay. And each pixel has the red, green, blue dimensions, and this will be presented as the long string, yeah, the RGB pixel 1, RGB pixel 2, RGB pixel 3, and so forth, yeah. Okay. Right, so this part okay, bahagian transformation. Okay, let me repeat. So under the transformation, yeah, you could have what we have done before. Discretize is actually one way of transforming your data. Means that you use binning, or you could use clustering. Yeah, means that you transform into one from numeric to the nominal. Yeah, okay, and then we have here, yeah. And then a concept of hierarchy, also transformation, normalization. Okay, so what's new here under this topic will be the normalization. Okay, what is normalization? You can have mean, max. Okay, and then you have z, yeah, z-score normalization, and also the decimal. Yeah. Okay, and then and then another one would be, yeah, another one would be a new way of data construction, which is your data could be originally in a very raw data, and you could presenting for image you could presenting in the RGB pixel. And another one example, apa lagi satu?
Aggregation.
Transformation. There is aggregation, yeah. So aggregation means that your data will be summarized, yeah, and be presented into one value, yeah, that shows it can be shown. I mean, it can shows the total. It can shows the other statistical measure that related to the modeling process. Okay, so this will be the transformation, yeah. Okay, and lastly will be on the part of reduction. Okay, so reduction, what do you understand about reduction? Have you heard about reduction, data reduction? Pernah dengar what is data reduction?
We reduce the data.
Okay, have you betul? Have you done on compression data?
No,
Data
I don't
compression?
think so.
Pernah
I
kan?
don't think so.
But I mean, for any task, you might have done compression actually, like what you compress your data into zip format or into RAR format. Pernah tak?
Benar.
Other than that, probably you have done on the image itself. For if you look at your image, indirectly you maybe notice or not, yeah, when you capture images in the in the form of using the camera phone and so forth, it's quite big actually. It could be 200 meg or 300 megs, yeah. And then when you send into the WhatsApp, it will be reduced, yeah. The size will be reduced, isn't it? Betul tak? That is one way of compression lah, yeah, data reduction and compression. Okay, so if you look at data reduction and compression, is very important in data mining. Why? Because sometimes we are going to look, we need to have smaller value data, smaller size data. Why? Because we want to make sure that the efficiency of analytical process itself. Somehow the process can be done using all, for example, you have thousands columns or thousands features. You want to use all, yeah, definitely can be done. But sometimes you can see if you done it half of the attributes, the performance of the modeling could be similar. So that's why this very important to show the efficiency. To look at, you have to done some of the experiment based on full data sets and also halfly or reduced data set. Okay, so rata reduction can be done on the attributes, yeah, can be done on the attributes and also can be done on the samples. Okay, so definitely clearly if you are done based on the attributes, your column will be reduced. How about samples? How about samples? Mean that? If you perform reduction on the samples, maksudnya apa? What does it mean? You reduce apa?
Reduce sampling.
Reduce the records lah, the sample itself, kan? Betul tak? Yeah. So probably you could have thousands of samples, you reduce into 10%, 50%, something like that. Yeah. Okay. So that one can be done. Okay. So as you see here, there are way of if you look at before this data reduction, aggregation is also considered as the reduction. Okay, and then selection definitely is a reduction, numerosity reduction, and also this one is concept of hierarchical, and discretization also as a reduction. Means that regionally your values will be vast, varies a lot, yeah, but you reduce it into 3 bins only, 4 bins only. Okay. So aggregation, this one do not have to repeat, but if you see this is the scenario, you could have quarter sales, yeah, but these sales can be presented as each year, and you could see here this is smaller size of data, yeah, and the presentation will be summary of the sales, yeah. This one could be another methods that new, yeah, compared to the aggregation, compared to the discretization process, yeah, and aggregation. What does it mean by finding minimum set of attributes? And this will be involve what we terms that is feature subset selections, yeah. In this process, it will look at the data sets and it will remove attributes among them. So methods could be done or could be implemented here is the forward selection or backward, yeah, back selections. So what is forward selection? It's very clear, means that this is all attribute that you have. So you will try to reduce data by performing experiment. Started from one data, one attributes, okay, and then 2 attributes, and then another set of attributes. Okay, if you look at this is presented by only A1, and then this is presented by A1 and A4. The next one is the 3 attributes. The rest attribute will be removed. Okay, so how do you select this attribute? It's not simply just like pick up it randomly. Okay, you could do that, yeah, but it might not efficient, or it might not giving you the best answers, yeah. So the next one is by using the backwards elimination, means that we start with the full data and then we try to reduce, yeah. Okay, so or it could be done by the decision tree induction. So this is both by the algorithms that can be later on you look at this classification. Okay, So for these two, there is a specific methods that can be implemented. What we call as the greedy heuristic. Maybe later on you will learn it under what we call optimization. Pernah dengar? Ya, pernah dengar? Okay, so also later on I will next week I will do this exercise, yeah, together with the classification process, yeah. Okay. So attribute subset selections, yeah, stepwise detection and combination. This one is just now that I showed you. Okay, I'm not going to go to detail on that. Okay, so why we have to do that? Because redundancy or irrelevance, yeah, is redundant data just now. Under the topic of integration just now, yeah. So redundant data could be could be apa dia? What is can you relate to the correlation? We have just now look at what we call positive correlation, and then we have negative correlation and zero. Zero, what is zero? No independence. So independence. So there no correlation at all. Okay, so if you have this if you have the remove like what you see here, purchase price and also amount of sales tax paid. Yeah, so amount of sales tax paid is always depending on the number of sales purchase price. Okay, and how about irrelevant attributes? Okay, so this is actually about removing. Tajuk ni sebenarnya lebih kepada removing. Which attribute you should be removed. Okay, so it could be would be the redundancy attributes, and then irrelevance attribute. What is the irrelevant attributes? Here, if you look at student's ID, does not have any impact to the student's GPA or or the results. Okay, so that's why I always inform students, remove any ID. Yeah, so remove any ID when you deal with the project task. Okay, sikit lagi. Alright, this part here. That one is on the compression. This one is data that can be compressed. You might use different presentations, yeah, different presentation for the data set. I mean, just now when you deal with image, you might look at a format that been presented as JPEG rather than PNG, because the size, the scales of the data have been compressed. Okay, and reduction. Okay, numericity techniques is actually also way of data representation means that it is sampling. So like a histogram. Okay, here this numericity reduction will be the process of. Okay, and clustering definitely you could see, yeah. So apa nama ni, this one and this one also. Okay, next sampling. So what does it mean by sampling? This is what we want to highlight here. Okay, so sampling, there are two methods of sampling. Yeah, there are two methods of sampling. This is what we call a random sampling. Yeah, so what is sampling? Sampling is by looking at the records. Yeah, discretization, the clustering is looking at the attributes, but now they're looking at how to reduce the data based on the samples. So there are two methods, popular methods. One is by finding the subset of data by using the random sampling. Means that you randomly choose any of the records to be to be used for the training process. So like currently you have 40k data set and you want to focus on 10 4k, or we call 10% of the data. So this is what you call as the random sampling. But the second method is quite rigid here, yeah. Okay, but before that, kita tengok dulu random sampling without replacement, and also sampling with replacement. Okay, so what is sampling without? Instead, when you pull from 10%, yeah, 10%, you pick up, you already pick up the records, yeah, you already pick up the records and put it as the temp sample. And these records will be okay. This record will be written to the pool. Okay. So and then you have to pick up another records to be put in the temp sample. Okay, temp samplings. Okay, until you have finished 10%. Okay, so selecting 10%. So sampling without replacement, yeah, means that you do not put the records back to the pool, yeah, will confirm that your data will not be testing. But when you have picking up the same records into the temp sampling, okay, there is a good and bad lah. There is a advantage and disadvantage lah for that. But it depends on the modeling process. Some of the modeling process might need this repetitive data for the training purpose. But for those who do not involve, who do not involve the training process, you might go for the one that without sampling, without replacement. Okay, and what is stratified? So stratified is quite unique here, because it look at the partitioning will be looking at the value itself, the value itself. So if you look at here, picking up the samples will be based on the value. Like if you are picking up 10% from the value, or in this example, it shows 50%. So 50% will be collected from records. So you only pick it, and then here at the middle age, you have 8 records. You only pick up 4. Okay, and for seniors, you only pick up 1. Okay, it means that in stratified samplings, it will look at the value itself and look at how many percent that you want to pick up, and it will be picked up based on the value. Yeah, clear? Understand? Boleh faham? Boleh ya?
Boleh, Madam.
Okay, alright.
Tapi Madam agak lag tadi.
Oh, ya ke? Alright. Tak apa, anything nanti kita boleh repeat lagi masa kelas tutorial. Okay, so that will be all under reduction. Okay, under reduction means that we can look at the in summary, we can look at the attributes part, or we can reduce is based on the samples. Yeah, so attributes just now, we can perform what we call aggregation. We can use we can use numericity reduction, which is based on the binning, based on the clustering, based on the linear regression. Betul tak? Okay, the new topic ataupun the new one that you see here under the feature selection. So feature selection could be done through the forward, betul tak? Forward and also apa tebal daripada situ adalah what we call it as back backwards. Yeah, backwards elimination. Okay, and it could be a greedy approach, which is called as the decision tree. Yeah, decision tree algorithms. Okay, and for sampling, okay, we can do the random sampling. We can do the sampling with replacement, sampling without replacement, and the fourth is what we call as the stratified. Okay. All right. So. Okay, so I think that's all for this for these 4 topics, yeah, 4 subtopics, yeah. Under pre-processing, that you have to look at data cleaning or data integration, transformation, and reduction. As you see, as you see, data discretization always can be used for the clustering method of reduction. Okay, so integration will be quite integration and reduction will be looking at the redundancy and irrelevant just now. Okay, you have to look at whether this data irrelevant or redundant. Okay, so how you look at the redundant data? How you determine whether the data is redundant? Look at the attribute type, whether this is a nominal or a numeric. So nominal, you can apply the chi-square, and then for numeric, you can apply the linear regression, for example. Okay, boleh semua? Senyap je semua?
Boleh.
Ya. Yang bercakap 2-3 orang saja, yang lain senyap je.
Need to review again this chapter, Doctor. Banyak sangat.
InsyaAllah.
Sama.
This topic is very banyak lah, tapi sebenarnya dia banyak repeat. Maksudnya ada benda yang is it has you can apply the same methods, yeah, the same methods. And if you performing project actually, yeah, performing data pre-processing could be taking you up to 60-70% of your time. Untuk buat modeling, untuk buat clustering and so forth will take you sekejap saja untuk you buat and then interpret. But in data pre-processing, when you have the data, you have to understand the data, you have to look at the noise, yeah, you have any missing value and so forth. You have to spend lots of time on data itself. Yeah. Okay, if there is no question, I think that's all. Okay, thank you too for those who have submitted, yeah,